Okay, so our next topic is, oops, something else in the chat. Okay, perfect. So our next topic is biconditional. I completely forgot about try it now 3 and 4. Okay, let's chat about it later if you want to discuss anything, or uh, I'll deal with it once we finish the exam. Okay, so now let's concentrate on the lecture first. All right, so now we want to see what happens uh, when we have a condition in our hand, okay, and what's the consequent of that, okay? So if I say that if it's raining, then I'll uh, pick up an umbrella, then I'm saying that if the first statement is true, okay, then the second statement must also be true. So that's kind of saying that whatever the first statement was, if that is true, my second statement is always going to be true. It's not, it can't be false. For example, let me give you one example from this. What's that? Okay, let's say example 21. If you upload that picture to Facebook, you will lose your job. So that means what it's trying to say that if you somehow upload that picture, if your friend somehow upload that picture, if that's true, then definitely he will lose his job. That means that next part of that statement is going to be true as well. And how, oops, someone has sent me a message. Let's see. What? I didn't understand. Try it now. 4. Okay. Okay. All right. So let's quickly. Okay. So we will use this sign. In maths, we say it looks like a tends to. Okay. Or you can say implies. Okay. Single imply. So this will mean if the first part of the condition, that is P, if P is true, okay, then Q is going to be true as well. And in the truth table, what we do, if the first part is true, we call it the antecedent. Let me show you the definition. Here you go. So the first part of the statement is called the antecedent, okay? And the second part is called consequent. That means the output, the result of that. So it's called the consequent. And we call P implies Q. Okay? And in English, you can say if P, then Q. That means if P is true, then Q is true. Okay? So in English, you can phrase it like this. If P, then Q. All right? So when you are trying to build a truth table with this, what you do is you just need to make sure what are the possible criteria of it. So if you remember, if you have two initial conditions, you can only have 4 criteria. If you remember the last time we talked about this, that is both of those are true, either of those are true, and both of those are false, right? We can only have one of these criteria if we have 2 initial conditions. Okay. Now what is the final condition? What is the final output? If P then Q, that is if we have P, then that implies Q. So we write, if you can see the screen, just the line above the box, that is whenever the antecedent is true, the consequent has to be true as well. So that means if somehow the antecedent is false, or rather the precedent is false, or the consequent is false, only in that case we'll say that the final condition is false. Okay, so let me start writing so that it makes more sense. And I want you guys to have the book open in front of you so that you can see what's going on. Okay. All right. Let's do it now. So today is 22nd. All right. So our criteria are, whenever we have 2 conditions, we can only have 4 criteria, as I said. So that's, let's say, P, Q, if P, then Q. Okay, P implies Q. And we can only have this criteria, of course. Okay, so for the truth table, as I said, the only case our final condition will be false is when the consequent is somehow false, when the antecedent is true. That means even though the antecedent is true, the consequent is false. Only in that case, we'll write an F. So only in that case, it will be F. Other than that, it will be true. So you just need to remember, in the truth table, P implies Q will be false if and only if the antecedent is true, but the consequent is false. Only in that case. Other than that, we'll have truth always. Okay? All right. So let's quickly do one example. Let's do a smallish one. Okay. Okay, let's try this one. So let's say we have a box like this, M or negation of P, and we have with it implies R. Okay, so that means this is the antecedent, this entire part is the antecedent, and R is the consequent. Okay, so that means if this is true, this will definitely imply that this condition is true as well. Okay, so we have already seen how to build up, how to build up a truth table for this kind of conditions, right? we need to have P, then we need to have negation of P, then we need to deal with M or negation of P. So I'm not going to do that now since we want to finish this topic. So you can check it after we finish. Since we have already done a couple of problems like this on Friday and even for your pre-class assignment as well. So I'm directly going to write this here, okay? So this is going to be false, false, true, true, false, 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 false. You can check, you can cross-check whether that's true or not, okay? And with it, I'll have the next condition, R, okay? True, false, true, false, true, false, false. Once again, you will not have this beforehand in the assignment or in the exam. You need to find it. As I am trying to show how you can solve this by conditionals. So that means I'm using this from the given conditions, okay? But for the exam, you'll have to calculate all this. This table will not be given. You'll have to calculate all of this before you reach the final condition, which is this one, sorry. Yeah. Okay, so now we'll see what happens. Okay, so the first condition implies R, okay? So let's see how can we do that. So as I said, the only case when we'll have a false is the antecedent is true, but the consequent is false. Here, this entire part is our antecedent, and this is our consequent. So we just need to find if there is any case where this guy is true, despite the fact this is false. Okay, let's see if we can find any of these. So this is true. So this will be true. Both of these are false. So this will be true. Both of these are true. This will be true. Here we go. We have a T in the antecedent, but we have a false in the consequent. So as I said, only in this case, we'll have a false in our final condition. Let's see if we have any more. So this is true. This will be T. This is both of these are false. This will be T. This is true. This will be true, and both of these are false. So this will be T. So that means it's actually easier to work with. If you just remember the condition for it to be false, you can see if and only if the consequent is false when the antecedent is true, only in that case, our final condition will be false. Apart from that, everywhere else it will be true. So it's actually easier to calculate, right? Again, I have already assumed that I can do up to this, but you have to do everything up to this before you actually reach this final table. So if you go back to page, let me see, page 419, okay, you will see the entire table is done there. You don't need to do this like the way they have done. Excuse me. Excuse me. like the way they have done, showing a couple of different tables. You can do that in the single table like this, like M, P, R, negation of P, M, negation of P, then you can have it here. So you can do that in a single table if you want. But yeah, if you do that in a separate table, this might be more efficient because there will be less room for errors, okay? But if you are comfortable, if you are confident enough that you can do that in a single table like this, you are more than welcome. Okay? Or even you can remove this one as well because you already have an R here. So you can consider that as well. Whichever format works as long as you are doing it right. Okay, now, any question up to this? Let's just take a break and see if you have any question. Just a quick reminder, if you have any doubts from the last discussion, if you have any doubts, if you are wondering how did you do truth tables for the previous discussion, then this might look sophisticated. So you need to clarify that discussion first, okay, the last one. Because we actually saw how we can generally build up a truth table. Now we are just observing different conditions, that's it. You'll definitely have one question in the next exam like this, where you will be asked to show a truth table. You will definitely need to show your work for a question like that. You can either upload it on that platform, I mean, My Open Math, when you are appearing for that exam, or you can send me email, whichever format you like. You need to write your work on paper. You need to take a picture of that. You can send me the picture, or you can convert it to PDFs and upload it, whichever you like. I have no problems with that. But don't try to write it on doc files or on LaTeX and waste your time, okay? Just write it on paper, have it precise and concise, and take a picture of it and then upload it, okay? I'll discuss more on the exam on Wednesday, but just a quick reminder, because the last time I remember, a couple of you struggled to do that. And of course, don't forget to show your work. Whenever you see a problem where you need to upload a file, that means you need to show your work. Each step could be really crucial. For example, if you, yeah, definitely we'll have one more example, yeah, because this is the last topic we'll have. So yeah, definitely we'll have one more example, yeah. So as I was saying, whenever you can see that you need to upload a file, don't forget to show your work. Try to show and expand each step, so that if you somehow go to a different result, I can actually give you credits for the steps you have shown, okay? So whenever you upload a file, just a quick reminder for that, okay? Okay, so let's do one more example real quick before we wrap up this content. So let's try, let's see, which one should we try? Okay. Okay, let's try one from the exercise, because I don't think we have anything tried now. exercise. Okay. Where is the exercise? Page. Page 445, is it? Yeah, 445. Okay. Okay, let's try exercise 5. Okay. On exercise 5, we have G for C. G implies negation of A. Okay. So we can try this, where G represents Elvis gained weight. Okay. So you can see in your book, that's exercise 5C. So G implies Elvis gained weight, and A represents Elvis is alive. Okay. Elvis is alive. So that's for A, by the way, not negation of A. Okay, and we want a truth table for this. Okay, so let's see what are the initial conditions we could have. Okay, G, A. So we can only have 4 because we have 2 conditions, 2 initial conditions. So the criteria will be TT, TF, FT, and FF, right? We want negation of A. So the next table would be negation of A. And negation, if you remember, is just the opposite of what you have. So true will become false, false will become true, true will become false, and false will become true, right? So that's the negation. And finally, we want G implies negation of A. That means, if you remember, we are only considering these 2 columns. This first one, which is G, and this third column, which is negation of A. So now we can ignore this one. You don't need to cut it. I'm just showing you don't need this one, right? Because we're working with negation of A. Okay. So, and for this conditional, we know that if the antecedent is true and the precedent is false, only in that case, the final condition will be false. Other than that, it will be true. So let's see if we have any conditions, initial condition like that. So for T, it's false. So the first one is the one we're looking for. It will be false because our antecedent is true, our precedent is false, as you can see. Both of these are true on the second row, so it will be true. Both of these are false. It will be true, and the antecedent is false. The precedent is true, so it will be true as well. So this will be our truth table. As you can see, if you understand what's going on, it shouldn't take more than 1 or 2 minutes. But you can spend more time if you need. I'm not saying that you have to do this on within 1 minute. 1 minute. You can definitely spend more time, but just try to imagine what's going on here. Okay. Any question from this one? Anyone? Try to do it step by step so that you don't get lost, because it's quite easy to lose your concentration somewhere in between and get lost. Because you can see each step is actually dependent on the previous one. So if you're working on this, it's heavily dependent on how did you do these first 3 columns. If you have done a mistake there, then the final output is somehow going to be, I guess it will be a mistake as well. It will be different than what you expect it to be. Okay. So this is conditional. Now, let's quickly see bi-conditional. Okay. So let's quickly go back to page, let's see. Okay, so where is page 422? Okay. So that's bi-conditional. Now, what does bi-conditional mean? Bi-conditional means we have, for the conditional, we have shown only single implication. That means P implies Q. Okay. So bi-conditional, your intuition should say that it actually works both ways, like this. Okay. That means P will imply Q and Q will also imply P. That means the antecedent and consequent are interchangeable. So this means P implies Q. That means if P, then Q, right? And this will mean P if and only if Q. That means if P, then Q. Similarly, if Q, then P. So it works both ways. Okay, let's quickly see an example and hopefully it will make more sense. Okay, so for the truth table, let's see. Sorry. For the truth table, we need P, we need Q, and we need the bi-conditional, which is P if and only if Q. Okay. All right. So first of all, we want to know what does this actually mean in the truth table. So this is actually rewriting of this. If P then Q, or if Q then P. As I said, it works both ways. That means if P is true, then Q will be true. Or if Q is true, then P will be true. That's why we say it's a bi-conditional. In the previous problem, it was one-way traffic, right? That means if G was true, we said A will be true. But we didn't say anything like this. If A is true, G is also true. We didn't say anything like that. Okay? But this one, we have a two-way traffic. That means it's either way. It's either from P to Q or from Q to P. That's why we have used this notation, if you remember. Okay? So instead of writing a big condition like this, we can rewrite it using this simple notation. Okay. Now, where can we have false and where can we have true? So once again, we'll start with the initial conditions, which is this. For every time we deal with two initial conditions, these are the four initial criteria. Okay. And now the final condition, that means the bi-conditional, will be true as long as the antecedent and the consequent both have true values. That means both of them are same. In simple English, both of those conditions, initial conditions, have to be the same. Okay, so that means if both of these are true, we'll have a true. Both of these are false, we'll have a true. And for the other conditions, we'll have F. So just a quick summary for you guys. If it's single implication, that means if P then Q, then if we have a row like this, where the antecedent is true, but the precedent is false, then it will be false. Other than that, everywhere else it will be true. But for the biconditional, if both of those are same, then we'll have a true, and everywhere else it will be false. So once again, you can see it's really easy to mix those and get lost, you know. It's really easy. And obviously this will be not provided as a formula. You need to remember this. That's the saddest part, but that's how it is. You need to remember the conditions for the truth tables. Otherwise, it's really easy to do a mistake. But if you know the conditions, if you know these two conditions, I guess it's really easy to solve a truth table, and within a short time as well. So I'm encouraging you to remember those conditions for the truth tables, because definitely it will be a question for the next exam, and it will have a significant score as well, okay, for that particular question. You might have more than one truth table on your exam, okay? Any question from this, from the conditional and the biconditional? Take your time. We can definitely chat more on this on Wednesday before we finally go for the exam on Friday. And again, if you have any problems appearing for the exam on our regular schedule, just let me know the reason. Then I can definitely reschedule it for you, okay? Other than that, the exam will be on our regular schedule from 8:40 to 9:30. It will be on my open math. And you will definitely have at least one question where you need to show your work by uploading a file on my open math, or you can definitely send me my email as well. You just need to write it on paper, take a picture of it, and upload it, okay? No more questions? Okay, let's try one more like this so that we can wrap this up. So let's try example 27, okay? We'll try to solve it entirely and see what's going on here, okay? So example 27, it says create a truth table for the statement A or B if and only if the negation of C. Okay, so we have lots of things to deal with. Let's start with our initial conditions. So that's for A, B, C, okay, so if you remember, if we have 3 initial conditions, we have 8 initial criteria. If you remember, so by any chance, if you don't remember, let me just quickly show what are the initial conditions. Here you go. We had 3 initial conditions, as you can see, and these are the initial criteria, right? That is, all 3 are true. 2 of these are true. One of these are true. One of these is true. And all the 3 are false. These are the possible outcomes, possible criteria, right? Okay. So now next, we can deal with either A or B or the negation of C, whichever you like. So as we have this as the apparently precedent here, so we can start with this. You can start with this as well. Either will give you the same result, so no problems. So A or B. Okay. Now, for A or B, you can actually ignore C. You don't need to look at what's going on here. Okay. All we care is these 2 columns, A or B. And if you remember, what does this A or B mean? A or B means at least one of these has to be true, right? Either A or B. We discussed it, I guess, 2 lectures earlier on Wednesday, the last Wednesday. So at least one of these has to be true. So let's see. So for the first column, both A and B are true. So we can have a true. On this occasion, both of these are true as well. One is true, one is true, one is true, it's true. Both of these are false, both of these are false. Okay, so if one of these, you have a true, a T for one of these, you can straight away write a T for it. Only if both of these are false, as you can see, we can have a false. Right? Okay, the next column is going to be the negation of C. The negation of C means whatever we have for C, we'll have just the opposite, right? So that means now we just need to consider this one, nothing else. We just need this column and we'll just write the opposite here. Okay, so we have a T here, we'll add F, it will be T, for T it will be F, for T it will be F, for F it will be T, for F it will be T, for T it will be F, for F it will be T. Whatever you had for C, the negation of C will be, if you just alter it, we'll get it. You'll get negation of C, right? Okay, finally, we are here for our biconditional, which is A or B if and only if negation of C. Okay, so now we consider this guy, this column, A or B, and the negation of C. We don't want to see what has happened in the previous 3 columns. We don't care now, okay? We only care the last 2 columns, which is here. And a quick reminder, for biconditional, if both the conditions are same, we'll have a T. Otherwise, we'll write F. Okay, if both the conditions are same, we'll have a T. Otherwise, we'll have an F. Let's see. So we have a T here, we have a F, it's different. We have a T and T, same, different for the next one, different for the next one. Both of those are same. Both of these are same. Both of these are same. This is different. One is F, one is T, so it will be F. So you can see it's really, really easy. Once you remember, of course, what are the requirements for it, and if you can eyeball it and make a synchronization of what you know and what you have, it's fairly easy. But once again, it's really easy to make a mistake as well. Okay, any question from this? So we have covered up to page 424. So your exam will definitely be on these topics. What we didn't cover, what we couldn't cover, those will not be in the exam, that's for sure. Okay, so a study guide will definitely consist of examples we have shown or we have covered, the try it now problems, and I will mention a couple of exercises as well. Okay, once we finish, hopefully by okay, so I have Chasm tutoring up to 5 p.m. today. So hopefully by 6 p.m. today, I'll definitely send you a detailed study guide. But definitely it will have the examples and the try it now problems. Plus it will have some exercise problems as well. I'll make an announcement of it. And on Wednesday, we'll discuss it. You can start solving the problems tonight once I post it, or if you want, you can start solving the examples. So a quick suggestion would be write down the question, hide the solution if you have it, try to do it by your own, then discuss it with your friend or show it to me, or you can check it by yourself as well to evaluate yourself, how well prepared you are, okay? And meanwhile, before the exam, if you want to chat about anything with me, we can always meet via Zoom. Just let me know which schedule works for you so that I can check whether I'm available at that period or not, okay? We can definitely make a schedule that works both for us and then chat. I'm more than happy to rediscuss these things in my office hour. Okay, just make an appointment before we meet. Okay, so that should be it from logic. We don't have any more time to cover any other topics. So for the exam, you can start early so that you can go over the topics more than once, ideally, before we appear for the exam. And anything else from your side? If you have any question, you can unmute yourself.